Great. Welcome to our live tech session, introducing the ArcGIS Maps SDK for game engines. First, just a little background on who we are. My name is Rex Hansen. I'm the product manager for the ArcGIS Maps SDK, and I'll be joined by Adrian Mario, the development lead for the ArcGIS Maps SDK.
Hey, everybody.
Great. Now, before we dig in, I'd like to provide a brief overview and some background on how we got here and why what we're doing is important. Now, over the past few years, we've seen a number of industries, enterprises, businesses pursue their next generation of 3D GIS solutions. Now, as these solutions apply to the real world, they need to leverage existing authoritative geospatial systems while taking advantage of new technologies to gather, store, and distribute geospatial information. Of course, Esri is the global leader in this space, and we provide the system to manage, maintain, and utilize geospatial data and analytics. And we are and should be at the forefront of defining new standards and technology to deliver access to high fidelity geospatial information. Now, these new 3D GIS solutions include client applications that target specific workflows that require photorealistic experiences powered by real world data. They need to take advantage of high-end graphics capabilities on modern devices and utilize hardware designed specifically to support extended reality experiences like headsets to power AR and VR workflows. These applications need to be highly interactive, responsive, and intuitive. They need to be designed to be visually compelling, immersive, and as realistic as possible to increase engagement, improve understanding, and optimize the environment for making decisions. Operationally, they need to support modeling and evaluation of phenomena in the real world, simulating natural and human-oriented activities, and the interaction between them in the past, present, and the future. In addition, they need to quickly render dynamic, real-time geospatial content accessible in the office and in the field for rapid analysis and decision-making purposes. Now, a number of industries have already embarked on this effort and are pursuing targeted solutions founded on game technology. Now, this is actually more than just gamification of GIS solutions, which is basically the use of game-style interaction patterns to drive and empower users of software. It's actually the use of game engines to build the next generation of 3D GIS clients and experiences on new devices with new expectations. And these industries include, and solutions include, AEC for urban planning, commissioning of new construction, evaluating work sites in the field, in defense and public safety for collaboration around battle and situation planning, for real-time monitoring, awareness and threat detection, and immersive yet cost-effective training, in natural resources to manage oil and gas pipelines and facilities, plan mining efforts and monitor infrastructure, in utilities to model resource flows, evaluate impact and visualize and manage assets in the field, in transportation to capture and manage geospatial assets, plan for new infrastructure and model vehicle movement, and in education to help drive a greater understanding of the world around us by delivering engaging experiences to do things like explore the eye of a hurricane or visualize potential impacts of climate change. So there is other client technology out there in the web and native space to build out 3D clients. So why game engines? Well, as game engines have targeted gaming experiences, it was essential that they deliver high performance, premium rendering of content with fast and fluid interactions to meet and compete in the gaming space. The highly competitive nature of the gaming industry helped push game technology and associated content and hardware to the limits of their abilities. As such, years of development have been invested by successful game engine vendors to build out premium, high-definition rendering pipelines to deliver simulated world experiences optimized for multiple platforms and form factors. Of course, to build a more immersive and compelling experience, game engines also invested heavily in systems and APIs to simulate the real-time interaction and movement of real life. The introduction of high-fidelity assets, physics engines, animation properties, atmospheric, water, and other special effects has enabled some game engines to deliver beautiful, photorealistic, cutting-edge visuals that appear and operate nearly identical to the real world. Now, game engines also provide support for targeting a wide variety of desktop and mobile systems and dedicated specialized hardware. So part of the next generation of 3D GIS solutions include business use of headsets dedicated to extended reality workflows, such as HoloLens and Oculus Quest. Game engines are built to support the responsiveness, frame rates, and the fidelity needed to power these experiences. And last but certainly not least, successful game engine vendors have existing developer programs and communities, help doc, forums, tutorials, and talented individuals and organizations that know the technology and that are available to do the work. With that in mind, we're delivering the ArcGIS Maps SDK as a developer product that integrates with the two market-leading game engines, Unity and Epic's Unreal Engine. The ArcGIS Maps SDK for Unity and the ArcGIS Maps SDK for Unreal Engine will be distributed as plugins, and provide a UI and APIs to access ArcGIS services and local data. This work is currently founded on support for local and global 3D experiences through a scene, which provides the context to display and interact with geospatial data and honor real-world geographic coordinate space. Now, the beta program is open to the public today. You can join anytime. You can use the URL in this slide, esriurl.com/A4GE. Nice and easy. Now, that's a high-level overview of these new developer products. Let's dig in a little bit, and we'll start with the release status. So the Maps SDK development team started building these new products back in 2019. We released our first public beta 1 last October, and the latest update, beta 2, in February, a few months ago. In that time, we've partnered with Unity and Epic Games, and we've started working closely with Unity's geospatial team and Unreal Engine's development team to deliver a premium experience for developers who choose to use a game engine with geospatial data and capabilities from the ArcGIS system. So let's run down what's available in the current beta release, and then we'll take a closer look at the status of our beta program. So here's a more detailed list of current beta capabilities. Now keep in mind, the functionality delivered in the Maps SDKs for Unity and Unreal Engine is equal, while functionality and capabilities of the editors and the engines themselves may be different. So development in Unity or in the Unity or Unreal editor is supported on Windows and Mac. And although Unity and Unreal Engine support developing apps for a variety of platforms, with this beta, with the current beta, you'll only be able to build apps that target Windows, Mac, Android, and iOS. A bit more detail on the support for Windows. This includes 64-bit apps on desktops and 32 and 64-bit UWP apps, which means we support use on the first and second generation of HoloLens. The Maps SDKs provide a couple options for working with the plugins. Both include a UI to configure properties of the scene, set camera position, and add and modify layers. Both include an API for developers to customize and deliver a solution in code. We also integrate with Blueprints, a visual scripting system in Unreal Engine. Both local or flat Earth experiences and global round Earth experiences are available. And data sources accessible by the plugins include a single elevation service for terrain, and this means an image service hosting Lurk encoded tiles with elevation values. This includes ArcGIS Online's world elevation services for terrain and bathymetry. We also support multiple raster tile layers, which include cached map or image data for display from a service or a local tile package or a TPK. Sources include ArcGIS Online base maps for imagery, topography, or street data. To add to that, we support multiple 3D object or integrated mesh scene layers. These layers are founded on i3S, an open specification optimized for the delivery and use of 3D data. So 3D objects can include textured buildings and structures, while integrated mesh uses a triangular network to represent continuous 3D surfaces, usually acquired by satellite or aerial imagery. They can be delivered as scene services or local scene layer packages, SLPKs. It's important to note that scene layers operate best in the Maps SDK when published with version 1.7 of i3S, the latest version. Version 1.7 includes some significant improvements to performance and memory usage, so we're certainly encouraging its use with the new Maps SDKs. It's also important to note that we do not support built-in access to feature sources, such as ArcGIS feature services in the current product. We will target in a future release, though. However, we do provide a location component to integrate custom content like game objects and actors within the scene established by the ArcGIS plugin. So as a developer today with the beta, the current beta, you can use this location component and craft a solution that retrieves or creates feature geometry and attributes to display and use in a scene. In fact, you can use the location component to bring in a wide variety of geospatial content to participate within the scene. Keep in mind the location component will not be necessary in the future, given some pending enhancements coming in the next release. We'll talk a little bit more about that at the end of this session during the road ahead. With that in mind, let's discuss the current status of the beta program. So the ArcGIS Maps SDK beta program has been open to the public for over a year now and has been incredibly successful. Currently, we have over 2,500 participants. Many of them are actively engaged in the community, prototyping solutions, providing feedback to our development team. And we've seen a few trends within the beta program over the last year. So far, interest in Unity and Unreal Engine is equal. In many cases, customers are evaluating both and they're keeping their options open. In addition, there appears to be an equal split between GIS developers, or developers with expertise and experience in GIS, and non-GIS developers. There's a wide variety of both new and experienced developers in the program as well. So in many cases, we're finding that GIS developers are just starting out developing with game engines, and non-GIS developers have game engine experience, but are looking to ramp up and take advantage of geospatial options and ArcGIS specifically. So at this point, most participants in the beta program are targeting a business or an enterprise application, sometimes called a serious game. In that respect, we're seeing pervasive interest in the use of geospatial data in game engines across many industries. So this includes AEC, defense, government, natural resources, utilities, transportation, and education. So it's really exciting to see and hear about some of the great ideas and the opportunities in these sectors. Now, with that in mind, I'd like to show an example of a business application, really a serious game. So let's hear from one of our customers, Simon Bowles, General Manager at EIC Activities, part of CIMIC Group, which is Australia's largest construction, mining, and services provider, about how the ArcGIS Maps SDK is helping them build their projects in the virtual world via a new initiative called Virtual Builder.
Hi, I'm Simon Bowles from EIC Activities. The best way to describe Virtual Builder is a flight simulator for construction. A dynamic, interactive, 5D digital environment where permanent and temporary elements such as materials, plant, and resources can be manipulated in time and space to create a virtual construction site. Construction is a highly complicated environment, often with hundreds or even thousands of people and machines working alongside each other. Unity's gaming engine and our event-sourced architecture provides the ideal collaboration and integration platform to make sense of this complex environment. By using physics and colliders to perform spatial temporal clash detection in real time, we can see what's happening, as well as what's going to happen as work progresses and plans evolve. This instantaneous feedback is incredibly valuable to us. ArcGIS Maps SDK provides the ideal stage for this virtual construction to take place. Powered by the ArcGIS system, it represents the starting point, the initial geospatial environment that gets transformed into the finished product. As this example shows, the key to Virtual Builder is that the rules work the same as in the real world. Things can't just appear of their own accord. They take time, money, and resources to build. Using data that is integrated across the design and construction workflow gives us some powerful capabilities, such as recursive computation and parametric modeling. Virtual Builder's ability to look forward in time enables our delivery teams to provide accurate and timely constructability input into the design process. Having good visibility of the future impacts of decisions we need to make now means better solutions for us as contractors, which ultimately means better outcomes for our clients.
So very impressive, and a special thanks to Simon and his team. What a great example of a business application using the ArcGIS Maps SDK to provide a geospatial foundation within a game engine. Now with that, I'm going to hand it off to Adrian, who's going to walk us through using the ArcGIS Maps SDK, show a few demos, and have a bit of fun. Adrian?
Thank you, Rex. So yeah, so Rex have been talking and giving a lot of context about what the ArcGIS plugins, ArcGIS Maps SDK plugins are about. And now I'm just going to go to dive in and actually show you what they look like. So I'm going to take control. Okay, here it is. So the first thing you'll do when you join the early adopter program, and you will actually land into that web page. The early adopter program is where you'll be able to download the ArcGIS Maps SDK for Unity and the ArcGIS Maps SDK for Unreal Engine. So as you can see, we released last month the beta 2, and 5 months ago, you can still download the beta 1. But that is also the space where we collect the feedback, where we try to understand the requirements, and that's where you can have a big influence on our roadmap and what will be released in the future. So, you know, once you're in the program and you've downloaded and start playing with the ArcGIS Maps SDK, go back to the early adopter website, give us feedback, send us exactly your needs, and then we can integrate that in our roadmap. We also have already available on the ArcGIS developer website, the Unity SDK and the Unreal SDK page available, where you can find all the information you need to get started, install the plugin, get some idea on what you can do a little bit more advanced, and also some of the latest capability we released with our beta 2, which is related to secure services and the use of OAuth. So this is, for ArcGIS Maps SDK for Unity and the ArcGIS Maps SDK for Unreal Engine. It's the same structure, same ID, and that's where you can get a lot of the help just by reading the documentation. Then, so let me just show you what it looks like. So once you have the, I'm going to start with Unreal Engine. And once you have the ArcGIS Maps SDK for Unreal Engine installed, you'll see that there's 4 samples to really get you started really quickly with the plugin. You can press play on the sample and actually look at what the scene looks like. And you see that it's, data of New York, and there's like transportation line, and there's the 3D buildings, and you can navigate into the scene and have a better look at what the scene look like. But we are a GIS company, and that's mean that I can actually fly wherever I want from there inside Unreal Engine, and maybe I can go on the other side of the earth and go to the Alps. So it might look pretty familiar and pretty, normal for you if you have been using, ArcGIS product before, ArcGIS Earth Pro, the Runtime API, the JavaScript API, and things like that. But for game engine developer, it is new to be able to access any point on the Earth and be able to travel to it. So let's look at what the sample code looks like. There's actually no code behind in that sample. Most of it is configured through the UI in the detail panel that you can see here on the right of your screen. So I have a global scene, which means I'm representing the data for the entire Earth. Maybe I can switch it to a local scene. I have where the camera is going to start. Now that I have a local scene, I can actually set up an extent as a square. So with right now, I think it's a 10-kilometer site. So now you can see that my data is actually limited to that 10-kilometer site for a square. But I can make it, really big, and then restart the application, and I will be able to do exactly what I did before, except that this time I'm not representing my data on a globe. I'm actually representing my data on a flat map. But it's still a 3D flat map, so I can still go anywhere I want and then be able to travel down the Alps and have that cool navigation effect there. So then in the rest of the plugin, you define which base map you want to use. Right now we're using the world imagery. And then you can add data. And you can see right now we have 4 different layers with all the different opacity. And some of them was a transportation, some of them was a building. And that's what created our scene. In Unreal, you have different way of creating a scene, and we have a sample for each of those. For example, if you prefer using C++ code, you'll be able to run that sample, and you'll see exactly the same experience you had before. Except that this time, this is created by code. If we look at the code, it's going to look really familiar to what we just saw in the UI. We're setting if we're going to use global or local scene, and then we added our elevation, and then we add the layers that we just saw before. Exactly the same concept, but this time written in code in C++. Another opportunity to write your application in Unreal Engine is using blueprints. So blueprint, for people not familiar with it, is it's a scripting language. And so if I open that sample, and I can look now on how I'm creating exactly the same scene once again, but this time using blueprint as scripting language. But the concepts are the same. I have my maps that I set local or global. I have my base map, my elevation, and that's when I add all my custom layers with a different opacity. So same concept. And once again, if I run this application, which is a blueprint application, exactly the same experience. I can navigate into the scene and look more on my data of New York. Those are the samples that come out of the box, part of the ArcGIS Maps SDK plugin for Unreal Engine. On the Unity side, it looks exactly the same. So Unity, you can see on the bottom of my screen over here, we do support 2 different types of rendering pipeline. So Unity has, I think, 4 different types, but we do support the HD rendering pipeline, so HDRP. This is really focused for like AAA games or very high-end definition application. Or we support also the universal rendering pipeline, and this is more targeting mobile platform and more compatibility apps that can run anywhere. In both cases, you'll see that we have 2 samples, and once again, one will use the API to. Actually, let me start with the prefab. So one we use the UI. To configure your scene, and you see that the UI is exactly the same as the one we just saw in Unreal Engine. This time we selected local scene. We have a circle for our cutting out our extent. But if I press play, you'll see my game view exactly the same application, except that instead of running inside Unreal Engine, I'm actually running inside Unity now. Unity has this really unique view, what is called the scene view on the left, and that's kind of the behind the scenes. So the game view will be what the user see, and that's what you see in on your main screen over there. But looking at behind the scene will really show you how the Maps SDK managed to be able to show data from the entire world without overloading your GPU. So if on my game view I start looking white, you'll see that behind the scene, the building are disappearing, and then the tiles themselves are moving to a lower LOD. And that's where we make sure that you always have the data that you need for your current visualization, but we don't overload your GPU with data that are not necessary to be rendered right now. And this is all streamed right now, and we could also support local files if you want your data to be local. Same principle apply. So if I zoom back in and look at that island again, you can see that the data is now fully loaded, and those 2 views looks exactly the same. So this is using the UI, but same in Unity. You can configure your scene using the API. And then if we look at that file over here, this is this file, and it's exactly the same type of code, except this time, of course, it is C#. And we set our viewing mode to local. We set our base map, our elevation, and all the layers we mentioned earlier, and the different opacity for each layer, and so on and so on. So exactly the same looking application for both Unity and Unreal. But obviously, game engines, the goal is not only to show data just in the game engines, is what you're going to do with it. And for this, the team had a little fun, and actually it's going to allow me to have some fun too, because I'm actually going to play a game. So I'm going to let the game go for a few seconds and let you emerge into the game, and I will explain later more about what's behind that game. Okay, so I'm cutting the sound that actually made the game, so it definitely was necessary to have it. So as you can see here, I have a big lizard working down in New York. I'm calling it big lizard because I don't want any copyright issues. And then some buildings that can be destroyed, and some other buildings that can be inflamed, and some helicopters that come and try to kill that big lizard. So that's a combination of different things. There's a lot of game objects going on, like really 3D models coming to the game engine, and also a lot of coming from GIS data. So let me show you what the data you can see. If I can reach it, here it is. So the data is the same data of New York that we've been using in the samples. So if you open it in the scene viewer, part of the ArcGIS platform is data that you can find on the Living Atlas. You'll see what the data actually look like. And that's really close to the data we just saw in our samples. Let me change the base map because the team used a dark gray canvas. And this is what is streamed to the game engines, depending on the position of the monster in New York. And you get those building stream. Obviously, in the game itself, if you look at the buildings, they look completely different. And that's because you have access in game engines to the rendering engine, and you can do all the effects you want. So you can see here that we have like a night effect applied to the buildings with light on the window. Let me skip the intro. With light on the window. And this is purely a shader work done inside the game engine. The data is still streamed from ArcGIS Online. And obviously those buildings that you can destroy and all those helicopters sending missile to our monster are all pure game engine 3D models and animated using the game engines. Same with the explosion of the building and things like that. But this is still a GIS application, and we can still be, thanks to the ArcGIS Maps SDKs and other REST API, we can still be part of the ArcGIS platform. And let me show you that now I have my monster surrounded by helicopters, and I can actually connect to a feature service, part of ArcGIS Online. If my tab wants to show up here, here it is. And if I refresh, you'll see that I can have actually my live position of my monster surrounding by a lot of helicopters here, showing up as a feature service in ArcGIS Online. So thanks to the ArcGIS Maps SDK, not only you can create some beautiful and very powerful visual application, but they also will be part of the ArcGIS platform, and you can take benefit of the ArcGIS platform and all its capability to be able to create your application. As a bonus, another advantage of running with game engines is the ability, the capability to run on different devices. So from the same application, we actually choose a different target and had to work a little bit on an AR scenario, but I'm now running on my phone, as you can see on my video feed. I'm running the same application. You can see it's an AR application, so you can see a little bit of my office. You can see my screen there. And then I can play the same game, but using my phone. Obviously, projecting my phone on the screen give a little less of a good experience, but you get the idea that that also can run on mobile devices and in AR scenarios. So to get you inspired even more about the things you can do, the power of the ArcGIS Maps SDK, I want to show again the video that Rex showed during our plenary on Tuesday and talk a little bit more about it. So the first thing you can see here is, once again, this is just purely an imagery and an elevation data that is streamed to the game engines. But by affecting the rendering of it purely on the game engines, you can do some things like edge detection, edge exaggeration, or really modify completely the look of the data. And here you can see that on the right, you have the data, how it looks in any ArcGIS product. And on the left, you have that Van Gogh effect that is applied purely by playing with the shaders inside the game engines. So the data is still streamed from ArcGIS Online. All the LOD are coming from ArcGIS Online, but you can do on top of that a lot more works that you cannot do right now with any of the ArcGIS products. Same thing working with shader. Here you just have a colorization of the triangle and of the mesh that just depend on the altitude. And here we purely rendering the edge of the data, not only an exaggeration like we saw in the desert example, but here purely the edge of the data. And this is a little bit more of the shaders that we use in the game I just showed you, where you can see the light coming up and the atmosphere effects that brings the nighttime to your cities. And this is not just, an image that is displayed on it. It's actually that impression that you can actually look inside each of those offices or space, and that's what you can do with game engines. Also, and I want to insist here, and I'm going to pause just for 1 minute. Also, there's a lot of things that you can do in Esri products, especially 3D Esri products like the ArcGIS JavaScript SDK, the Runtime SDK, the Pro, obviously, ArcGIS Pro, that you can actually do even without an API for it. You can do it natively in game engines. You can write your own, so you don't have to, you don't have to use the color scheme that we have in JavaScript or we have in Runtime. You can actually recreate that entirely, because once again, in game engine, you have access to the rendering engines that's powering the scene, and you can do something like the measure tool, view shed, and others, line of sight, and other capability like this. That's a simulation showing that traffic like stops, let other cars going in, and pedestrian waiting for the cars to go by before resuming. And that's also a really good combination of GIS and game engines rendering. Here we have a little bit more on the drone hive that Rex shown during the plenary, and there's a lot of GIS to it because you have some no-fly zone. You have, when you're getting low of battery, you need to go to a charging station. We need to make sure that paths don't cross at the same time, so we don't have, two drones basically running into each other. So that's a lot of examples on where GIS and really good 3D visualization comes to life using the ArcGIS Maps SDKs. So hopefully, all those different snapshots of things that can be done really inspired you. And once again, please join the early adopter program. Give us some feedback, and we're definitely monitoring this, and that has a direct impact on our roadmap. So with that deep dive into what the ArcGIS Maps SDKs looks like, I'm handing it back to you, Rex.
Great, thanks, Adrian. Let me get the screen back on my side here. All right, can you see my screen?
Yes, I can now.
Okay, cool. Great. Thanks, Adrian. Interesting to see the game that was built there. Maybe well-timed given a recent movie that was released. Not sure, actually. So anyway, not going to say anything more about that.
It's missing a big monkey, I think. But
I think it might be. Exactly. So well-timed, well-timed. So with that, let's take a brief look at the road ahead. Now, given some of the feedback and the difficulties that we've seen expressed on the beta forums, we have a few tasks on hand for our next release, which is a pre-release scheduled for June or July of this year. Now, one important aspect of using the Maps SDKs is the ability to place content in geographic space. And as game engines don't have support for this today, we've had to work around this limitation in the Maps SDKs, and it's made the developer experience more difficult than it should be. Now, this is especially noticeable when combining game engine or custom content with ArcGIS layers in a scene. Fortunately, as I mentioned before, we've been working closely with Unity, with the Unity and Unreal Engine development teams, and they certainly recognize the value of including native support for geospatial placement. It will provide the Maps SDKs with a refined, responsible native API experience for building solutions that combine ArcGIS layers and supplementary geospatial content in an application. It will also improve the ability to set camera orientation and placement, which is obviously important. So Unity and Unreal Engine will support the ArcGIS Maps SDK in this effort to provide a native geospatial placement. And we plan to work closely with their development teams to make sure the Maps SDK is in line. So native geospatial placement is critical to our next release, but we also plan to deliver other enhancements, such as support for multiple spatial references, not just Web Mercator and WGS84, simplified AR experience, which will take advantage of the native geospatial placement work, access to geometry and attributes in a 3D object scene layer, which will deliver intelligence with features for an interactive experience that needs to display or use attribute information. We also plan to keep up to date on the latest i3S spec for optimized use of 3D data formats with the ArcGIS system. So working with the next version, i3S 1.8. Of course, all of this is subject to change, so I need to qualify that. Now, the first production release is scheduled for Q4, near the end of 2021, near the end of this year. So what will this first production release, version 1.0, include? We're looking at a few items, and we're keeping our options open at the moment because there's quite a few projects in play. But some of those items might include, and we're considering the following, a host of new layer types. One of the primary benefits of using the ArcGIS Maps SDK is access to ArcGIS data sources, things like building scene layers and point cloud scene layers. We're also looking at targeting single LODs, levels of detail, to support elevation layers as terrain and landscape, access to ArcGIS symbology to deliver complex cartographic representations, such as those designed for military specifications. In short, there are quite a few opportunities in this space. So we'll be working with our partners and our customers. We'll be working through the beta program and individually to assess needs and priorities as we go. We're going to keep this dynamic. And as time goes on, we'll see priorities crystallize and we'll see some of these enhancements start to come together. I want to finish this presentation with a reminder that our beta program is open to the public. The link to join is available in the slide. So any feedback on the ArcGIS Maps SDK beta or any questions on our developer efforts with game engines can be handled in the beta program, user forums, or feedback channel. Also, feel free to use the beta program to ask any questions or share details about a use case you'd like to target and discuss. So with that, remember to provide your feedback for this session by clicking on the session survey below the link. And I think what we're going to do now is I'm going to go back to this slide. I'm going to park it here. We'll leave this up so you guys can get the link and details. And then we're going to go into a Q&A portion of the session. And we've got ourselves a pretty sizable chunk of time to answer some questions. So what we're going to do is go out and take a look at what's in the queue. And we'll top down at this point. Great. So the first question we have is, will this be a priced product or free? If priced, what's the model? So that's a great question. I did provide a reply, a fairly extensive reply. Now, basically, because the ArcGIS Maps SDKs are in beta, the cost associated with the distribution and use in a production capacity hasn't been officially determined. We're currently thinking it's going to be free at this point because we'd like to provide it as a way to enable or catalyze access to the ArcGIS system. But of course, there is a cost to use parts of the ArcGIS system, such as ArcGIS Online or ArcGIS Pro, ArcGIS Enterprise. So something to keep in mind there too. But that's our initial goal, is to keep it available at no cost. But we'll see how that goes. Again, always subject to change as this moves into production. The next question, working down from the top based on the likes. I need access to dynamic map services and point clouds. When will they be available? They're certainly on a roadmap. Of course, we're always, as I mentioned before, the ability to access different data sources through the ArcGIS system is very important to the ArcGIS Maps SDK. It's critical as a conduit or as a mechanism for accessing ArcGIS data sources, whether services or local data. They're on a roadmap. Obviously, we're looking for for some feedback on use cases to help assist or bolster the priority of some of these data sources. There's a lot of different competing enhancements, so feel free to use our beta program and provide information about some of the use cases there too. Next question is, are there plans to include the demos shown in your beta packages? Adrian, do you want to talk about that?
So yeah, we are actually planning on sharing the source code, but we do want to share the source code only when the Geoplacement framework that Rex just mentioned is available. So with pre-release, with both game engines really natively supporting GIS placement of game engine resources, because we don't want to direct people on using one way when there's a way better way coming up. So we will share the source code of what can be shared of the source code after pre-release.
Cool, thanks, Adrian. And I think we've got another one here, which I think you've answered, but we can talk to it out loud. Are there plans to integrate with any of the third-party visual scripting systems in Unity? Actually, this might be one for me. There's no specific plans actually for that, but obviously interested in some of these opportunities. Obviously, getting into the game engine space, Esri getting into the game engine space and developing solutions with both Unity and Unreal Engine. There's a lot of open opportunities in that space, and so we'd like to hear about maybe some of those opportunities and use cases that you have. Our beta program is a great place for that. Please provide us with feedback. Because of the sort of the breadth and depth of opportunities, some of these things we'll have to maybe look into and investigate. Use cases help, but we'd certainly like to consider any and all. So feel free to provide us with feedback there. Next question, your presentation is not accessible on the website. Could you please publish somewhere? Yes, so this session, the video for this session will be available after the Dev Summit. The presentation may be available. We'll see how that gets distributed. This is a live session, actually, so we were basically working up to the last moment, trying to get all this information kind of ready for you guys to enjoy. Do you plan to support other game engines besides Unity or Unreal? At this stage, no, but we're always open for opportunities again. So if there is another game engine out there that there's a great use case for, and you'd like to be able to investigate or see if there's something we can support, we have architected the ArcGIS Maps SDK to be very flexible. So keep us in mind and let us know what those opportunities are. Let's see here. Next question.
I think
John.
the next question from John is about somebody that is new to game engines, and then for the first time experiencing getting everything set up and working in his scene, but then the workflow to get it actually getting published is sometimes a little bit difficult and definitely need more help. So we are constantly updating our documentation, but it's really, if it's purely about publishing your application for devices, then it's more a game engine documentation that you need to look at. But we'll definitely understand that we need help. We understand that we need to provide help because we're bringing a bunch of users that are used to just ArcGIS product and GIS into the game engine world. So they do need a little bit more help. Keep in mind that right now our documentation is still for beta. So we're definitely working on it, and we'll try to help you more into not only be able to create your application, but also be able to create to export it as a desktop application or as a mobile application.
Yeah, great info. So another question popped up at the top here. Is it possible to edit my scene in Unity or Unreal Engine and sync the changes to my server or portal? That's a great question. I'm assuming that you're working with features that are coming from an ArcGIS layer or ArcGIS service or layer. In this case, it's probably a service because you're talking about server or portal. Now, technically, we're working with a RESTful API, and that REST API that enables access to the ArcGIS services provides a fairly comprehensive set of operations and capabilities that those services include. Now, there's nothing out of the box today that supports editing with the Maps SDK, but the REST API that we use, that we're using behind the scenes, and that is available through services that are hosted on ArcGIS Enterprise or through ArcGIS Online, is available for you to use. So right now it'd be a custom solution, and it'd be founded on REST API capabilities. Let's see, next question.
So I actually bumped up two questions that are really related. Is how to deal with large value for camera position, and then there was actually moved. Is it possible for us to do a world scale AR with the game engines? So the answer for the well-scale AR with game engines, yes, it's totally possible. So as you can see, I was directing the camera over the earth, and I was going from one side to another, and that was pure, GIS positioning there. So if you connect that GIS positioning to some device that actually gives you, a good position in the real world, then you can combine the two and get some video feed, and then you'll be able to actually do some real scale AR, world scale AR. Be careful that, world scale AR, the huge issue is going to be your actual positioning. You cannot rely just on GPS. Even the very, very expensive GPS, depending on what kind of world scale AR you want to do, are not going to be precise enough. If you're just looking at a mountain top, that might be enough. If you want to know if you can dig, if there's a pipes underground, you need something really precise. And that's where the problem is going to be, is get that positioning and orientation of your device correct. So technically it's totally feasible, but I think the downfall will be try to use those sensors on your device that might not be precise enough. And the second question I bumped up, but it keeps on being moved. It was talking about the Geoplacement Framework and how easy it is with camera position. So both Unity and Unreal are basically releasing kind of what we call the Geoplacement Framework, which will give you a full GIS position of the camera. So you'll be able to, instead of having your camera positioning in kind of game space, you'll be able to have like a WGS84 coordinate, for example. And that's how the camera inside the game engines for both Unity and Unreal will be placed. So that will basically really deviate any problem you might have, not only placing the camera, but placing other game objects inside Unity and Unreal Engine. So this is why we've been working with both Epic and Unity on that, and we're super happy that we'll be able to offer that. Well, they'll be able to offer that, and we'll be able to take advantage of it. And it will make that really easy. That says, in that question, there was a question about the physics. So that's a little bit more deeper in the details, but having the coordinate system fixed where you can go anywhere you want. We still have the translation that is done when it's passed to the graphic card that only supports 32-bit precision. So we still need to do some magic and some repositioning there. And though that is still going to happen, we still need to be able to change our origin depending on where you are in the world, to make sure that the physics and everything that's happening around the current camera position is still happening and is still working. So, Unreal Engine has a version 5 that might support 64-bit precision, and Unity has a repositioning that actually doesn't cost anything. So those are different answers per game engines. But the answer is really separating the positioning system, which right now should be with what Epic and Unity are working on, should be very easy to use, and still some rendering, underneath what's going on. We still need to replace the origin because of that single precision inside the graphic cards.
Great. Adrian, there's a next question at the top. In Unity, will we be able to access the generated objects outside of runtime? It'd be nice to be able to customize and have persistence. I know you have a preview capability. I mean, creating prefabs.
So you want to be able to access the generated object outside of front. Oh, so yeah, we have that. It's not in our roadmap yet. It's more in that to-do list that we share. And then we actually, internal story that between beta 2 and the pre-release, we're actually doing a lot of low-level refactoring. And one of the goals of that low-level refactoring is to be able to allow us to do just that, to be able to see the scene and look at the scene before you actually press play. So we're working on that. I'm not promising anything because we need to see the results of our refactoring first, but it's definitely in our roadmap, or at least in our things to implement.
Good stuff. So next question, Adrian. Do you plan to update the documentation with samples that combine GIS data and actors? I'm assuming Unreal Engine then, specifically, or some documentation about location component.
So yeah, we're going back to the discussion we just had on the geoplacement. The location component will disappear with pre-release and will be replaced by both solution in Unreal Engine and in Unity, with what both game engines are gonna add to their placement system. So that's why we haven't updated the samples between beta 1 and beta 2, because we knew that was coming in pre-release. So there's going to be a lot of if you invest a lot on beta 1 and beta 2, you're going to have to do a lot of changes to move to pre-release. And we think it's actually easier to start with pre-release, because those placement will be purely native to both game engines. And this is why we're not going to update the samples right now. But obviously, when comes pre-release, we will have the samples and the documentation that will show you how to take advantage of that geoplacement framework from both Unity and Unreal Engine.
Great. So the next question, in Unity, did you create your custom shaders using Shader Graph? And if so, can they be included in the SDK? I think the maybe I could answer this from a higher level. So we've got a number of demos, a few things that we showed yesterday in the plenary and today in the tech session that relied, or at least was founded on, working with custom shaders in a game engine. We're looking into what we can deliver and what we can share with those custom shaders in the context of a demo, or maybe the source code for that demo that we can share. Then we can comment a little bit more detail on that at this stage. So we're looking forward to that. Hopefully in the future here, in the near term, I'll be able to share more details on that.
And once again, doing the re-architecture we're currently doing, we're also looking at a faster way to be able to write custom shader and integrate them into the rendering of the Maps SDKs. So it's still, we don't want to share what we have right now because it might change again. But everything I showed you was done by a team purely using our SDK as a user. So basically downloading beta 2 and only building on it. There wasn't anything that was added to be able to the ArcGIS Maps SDKs themselves to be able to produce those demos. So everything we showed you can be done today just using the beta 2.
Great. So next question, can this be tied to real-time data from online maps, assuming ArcGIS Online, for example, like field maps, and can you push data or edits from this to an online environment and create a real-time interactive environment? Certainly, there's no support directly for this within the Maps SDK today, but we are looking at enhancing the Maps SDK where we can to support really real-time data. Working more effectively with feature services, stream services, real-time data in the future. That said, as I mentioned before, there is a RESTful API behind our services, and so it would be a manual lift today. But there's no reason why you as a developer wouldn't be able to build against that and leverage or work with those features in real time today. Now, that said, the services that we do work with today, working with scene services and raster tile layers, if there are changes or updates to those services, we will respond and respect those. So there is some level of that support today.
Yeah, and for the demo, we just show the position of the big lizard and the helicopters was pushed to using our REST API to a feature service. So it's totally feasible today. It's not out of the box.
Next question, will the runtime database, assuming that's a mobile geodatabase, be a supported data source? That's a great question. It's on our roadmap to be able to support as really a local data source and the ability to store features, but not just features, but also rasters. So that's sort of a new capability, a new primary data source within the ArcGIS system. And so we're certainly looking at opportunities there to work with that as local data. Let's see here. Next question, any plan to develop SDKs or APIs for robotic simulators like Gazebo? Again, great question. Would love to hear some of those use cases out there of what you guys are looking to be able to support and how we can contribute. Feel free to feel free to use our beta program to submit some of those ideas. I have to admit as well, I think the second slide of this session, we did provide our email, but at the same time, we're both active on LinkedIn. So feel free to reach out there and connect up with us too, if you'd like to work a bit more privately. Obviously, the beta program is a great place to go if you'd like to share. Let's see here. Next question: is custom elevation data able to be brought into the scene? For example, a DEM layer for local, more precise elevation. Would this data be able to be manipulated from inside the game engine, such as editing the raster or moving polylines? Adrian, you want to take that?
So we are considering, so we do support right now online and local for, it could be scene layers, it could be imagery, and we actually don't support the local one for elevation. And that is something that we want to work on before we release our first version. I'm not promising anything yet because obviously our roadmap for the final version is not set yet, but it's definitely something that we want to look at. We will first need to support multiple files because usually the DM files come in very small area and you just combine them. So we will first have to support multiple elevation and then support the local one. But we are really trying to get that done for final, but no promises because our roadmap is still undecided at this point. For be able to manipulate it inside game engines, the answer is yes and no. And there's a license part, and I will move that back to Rex. But there's also the technical part where what we render, especially coming from services, is a lot of different LODs. So if you modify your mesh for this camera position and then you zoom in, your data will be lost because you're gonna have a new mesh coming from the ArcGIS Online. So you have different ways you can deal with that. You can just set your camera position, that is the ArcGIS Maps SDK camera, and that way you don't get new LOD, and then you can modify your mesh and then export it if you want it. So that would be the primary way to use it. We're also thinking about having something that completely remove any elevation in there, and that way you can just come up with your own terrain for holes basically in your data. But once again, there is kind of a licensing issue there, and pushing to Rex on that one. But there won't be, I don't think there will be anything out of the box anytime soon in the Maps SDKs.
Yeah, so there is a concept within the ArcGIS system about modifications to integrated mesh for elevation that we might be able to use in some capacity. It's still formulating at this stage. Licensing could be an issue in the sense that the data that you're using may or may not be able to be manipulated dynamically. So something to be considered at this stage. So something to think about going forward. But obviously something we need to pay close attention to and light up when we can. Next question: how do we deal with large values for camera positions and the physics system?
That's the question we answered earlier, and I couldn't find that question again.
That's the one that's the one you're answering. Okay, cool. Let's see. Unfamiliar with gaming engines, will C++ or C# be required knowledge for development? Depending upon whether you use Unity or Unreal Engine, probably preferred to know one or the other at this stage. So C# obviously for Unity, and C++ for Unreal Engine. It will enhance, while not absolutely required, it will enhance your developer experience greatly. So it is actively encouraged, I would say.
And a lot of users use Unreal Engine using blueprints. So you don't, there will be something else in addition to C++ or C#, that scripting language blueprints. But yeah, you can do a lot of things without coding, but obviously coding will bring you further away.
Gotcha. So another question about the mobile geo database, the Runtime geo database. Great question. Of course, it's on our roadmap. We're going to keep close watch on this and be able to use the mobile geo database as a local data source going forward. Great option going forward within the ArcGIS system as a whole. Next question: the building which you lit up in your demo was Unreal Engine actors or a building from an ArcGIS Online scene. Can you share some links on how to do it?
So there was two types of building in that demo. There was buildings coming from ArcGIS Online that was providing the New York data, and they were black with just the windows, and that was done using a shader on top of the mesh data coming from ArcGIS Online. And once again, we will share the source code, but we'll share the source code, but we will do that after pre-release. And the other buildings that were completely light up with the the monster could actually destroy, those ones were purely game engine resources.
Cool, thanks, Adrian. Then the last question before we finish, national coordinate systems other than WGS84 and WebMercator and local scene are also supported. We intend to support those. We're looking to support those at pre-release at this stage. So that's our current target. So yeah, great question. And with that, I think we've reached the 12:30 hour. Thanks everyone for joining us, and thanks for the great questions. Looking forward to meeting you guys in the beta program and in other communication forums. So thanks again, guys.
Thank you very much.